Okay, so finally we can continue. Now because we are running a little bit behind because of all our technical issues, we are going to continue with the lecture which we started on Monday. We'll finish that and then we'll carry on with the tutorial. It's not set in stone whether or not we do a lecture or tutorial content in a tutorial period. That's why it's compulsory to attend, or especially if we run out of time for whatever reason. The reason why I need to do this first is because with the tutorial which I'm going to go through, you need to understand some of the differences theoretically before we can actually see it in code. So last we left off, we had a look at Java as a language. We looked at the way conventional compilation worked. You had source code, which was then compiled into machine code, linked, gave it an executable. And then yesterday in the practical session, we had a look at how Java does things a little bit differently. You compile things into class files, which is bytecode, and bytecode runs on the Java virtual machine. Now, we need to talk a little bit about the actual Java virtual machine, because that's how Java can be used on any platform. We saw Java bytecode, we saw the class file. You couldn't actually read the contents of that actual file. It was, to us, a bunch of gibberish. Didn't make sense. But that class file basically allows any Java virtual machine to interpret that code. It will read it line by line and interpret and do whatever it says it needs to do. So what that means is wherever you have a Java virtual machine, you can run that code. That's why we have these two things. We have the JDK and we have the JRE. The JDK is for us to develop Java source code applications, and the JRE is to run them. But you'll notice that everything that's specified here as a Java language eventually, right to the bottom, runs on the Java virtual machine. So what is a virtual machine? Anyone care to take a guess? What is a virtual machine? What does it mean to be virtual? A computer in the computer. Almost. It's virtual, means that it's obviously not physical, it's virtual, it lives in digital space. And machine, like the person said there, it's a device that exists inside of the virtual space as a machine. It has components that needs to work. Now you do get simple, I would say simple, not in the sense that it's very simple to code those type of machines, but you do get simplified virtual machines and you get complex virtual machines. You do get a way to run a full operating system virtually in a virtual machine with virtual CPUs, virtual RAM, all the different components, but you also get a slimmed down version of virtual machines, which is something that is like the Java virtual machine. So what this does is it provides a standard interface to work with the underlying operating system. Java virtual machine on Windows understands how to do all things Windows. A Java virtual machine on Unix understands how to do everything on Unix. Same thing for a Mac, same thing for ARM devices like a phone or a tablet, or embedded devices. Embedded devices are things like microwaves, are things like washing machines. You can, not very common that we might see and use ourselves, but you can have things that are programmed with a programming language like Java for things like your microwaves, your washing machines. Nothing else easy that comes to mind at the moment, but that's places where you can see some of those virtual machines. Obviously, it doesn't have a full operating system experience. You don't have Windows running on your microwave just yet, but you do have an interface there. You have a little screen where you can press buttons and it does something. So with this virtual machine, it translates your bytecode into something that the operating system can understand. That's why Java can do platform independence. It doesn't need to run on a specific platform. As long as you have the Java virtual machine, your code should work. Should. Because there are certain things you need to take into account when working on different operating systems. Some of those were covered by later versions of Java. So the initial versions of Java didn't do so well, and then they sort of fixed it up over the years. Right now, we're running Java version 17, and you would have seen it said LTS, long-term support, and that's something that you need to identify with quite well. When you're working with software and you're working with different versions and you're working operating systems, support is a very big thing, especially when you go out into industry. You want to make sure you're working with software that is still supported. How many of you are running Windows 98 at home or on any machine? Windows 2000? Windows Vista? No. No. Vista was not a good experience. So with that, you'll see that the companies that provide the software will say, this is at end of life. You will not be able to get updates anymore. You can still use the thing, but if something breaks, you're on your own. Same thing applies to things like working with C++. There's different versions of C++ as a language and different versions of the compilers that are available. Different versions for different operating systems, different versions for different systems, whether you're using a 32-bit machine, 64-bit machine, etc. Same thing applies to Java in the sense that there's different versions and they're supported up until a certain point. You might have seen on the Windows machines, if you have a laptop, or you might have seen it in the labs, where you have a certain version number. And if you go visit the Microsoft Windows web pages, you might see that it will say, this version is supported until 2022, until 2023, until 2025. So the same thing happens with Java. Different versions are supported until a certain date. Now, with long-term service, it means that that version will be used for a long time. It will have support for a long time. You might see other versions like version 15. It doesn't have long-term service. Version 15 is only going to be supported up until 6 months after the next release, which was 16. 16 got released. 6 months later, version 15 no longer supported, no longer updates, no longer has anything that happens with it. So we on 17, and hopefully it will stick around for a while, because that was only released end of last year, beginning of this year. So with the right version of Java, we now need to look at what is the similarities and differences between Java and C++. You know C++. At least I hope so. How many of you remember how to write C++ code right now? A few hands. All right. So those of you who are on Blackboard, hopefully it's still running. I did manage to get on eventually. I will check the chat when I come to a section. So if you are having questions there, we'll have a look at it. We're going to see how we're going to handle this, because trying to go back and forth between chat and live is very, very taxing, and it obviously eats a lot of time. So I'll have a look in just a moment. So hopefully you still remember most of the concepts. Do you remember classes? Do you remember virtual functions? Do you remember pure virtual functions? And what about structs? Function pointers? Okay, less people saying yes now. So we're going to look at what you know and how does Java do those things. So one of the first things you learn about is after you learn hello world, one of the first things you learn about is hash include. What's hash include? What it's for? It's to add additional functionality that's available in another library, in another section. It's to add extra things inside of there. So what is hash include? What is that thing? What does the hash mean? You have hash something else for other things. In your header files, what do? What's the first thing you write in the header file? Hash if def. You remember that? Hash if def? Because when you include your header file, you don't want to be included multiple times. So you had a hash if def, and then a hash define, and then a hash end if. All of those are called macros. So you had macros that you could use, and macros can get really complex, especially when you start working with templates and templates that generate templates and templates that need to generate Python code. All of that is very powerful. Java said, nah, no thanks, too much headache. So Java doesn't have any preprocessor. What is a preprocessor? Something that processes macros. There is no hash include. There is an equivalent thing, but it's not a preprocess, part of the normal language. In terms of data structures, you'll see that both C++ and Java have classes. We've seen the class yesterday. We wrote a hello world class. We had a main method. So you have similarity there. You do have structs in C++, and in version 17 of Java, we do have something called records. However, we're not going to go very much in depth into that. So it is available, but it's not something we're going to look at right now. C++ has something called unions. Unions are basically a way to tag a section of memory as two different types, two or more types. And then with Java, you have something called enumerations, which is also available in C++. What's an enumeration? Anyone? So in C++, an enumeration was just numbers. You could assign a special name, equals 0, equals 1, equals 2. That was an enumeration. It wasn't really special in any way. With Java, enumerations have the same level as classes. They're like a class. What do you use enumerations for? Enumerations are for specifying something that can only be certain types. What I mean by that, if you think an example I can give you is, if you look at email priority, you have important email, normal email, and low priority email. That's what you usually get. That's the three that you usually get. Does it make sense to have something like a pink priority? It's not one of those three values, so you should never be able to put that value as an argument, as a parameter to a function. You should only be allowed to use those three values. And that's what enumerations do. They make sure you only use enumeration values that are valid. So Java enumerations take one step further. They are class-like in their structure. They're like classes. They can work with superclasses and subclasses. Parent-child relationships. You can work with those in enumerations. Then there's also something called interfaces. Now, interfaces are very similar to working with pure virtual functions inside of a specific class. There's no implementation, just an indication that you need to do something if you extend this class. When we get to object orientation, we'll talk about those in more detail. Then we move on to domains and visibility. So with domains and visibility, it's basically talking about how do we group code together and how do we make them accessible. So with C++, you had namespaces. Using namespace, working in a namespace, you had a way to group your code together. C++ has public, private, protected. Same thing available in Java. You have public, private, protected. What does public mean? I know exactly what to put in the class test now. So what does public mean? It's available to anyone who has access to that header file wherever you define that thing. What is private? Private is only allowed in that class itself. And protected, it's accessible in the class and any subclasses. Then you had something called friend. What's friend? What's friend? That's when one class likes another class and say, okay, you my friend. You can access certain things that are only allowed by the things I specified. C++, the only language where your friends can access your private parts. Wow, okay. You guys are really tough crowd. Tough crowd. All right. In Java, we don't have friend. We have something called package. And you'll see that how we group namespaces is the equivalent in Java is called packages. Anyone attempt the bonus question yet? No? Anyone attempt a practical at all? Okay, a few people. Proactive, that's good. I would suggest that you try and do the practical before Friday morning. I know how students operate. Oh, it's due on Friday. Okay, I'll start Friday morning, half an hour before it's due, and then complain to the lecturer when I can't submit 5 minutes before the time. Right? Don't do that. Doesn't work out. Especially when you go on to later modules in your degree, i.e. third year, when your practical is due at the end of the session when you get taught the stuff. Doesn't that sound like fun? You have 3 hours to complete the practical every week. So rather get into the habit of trying to do something as soon as possible. Now everyone's favorite subject in C++, pointers. Who likes pointers? I like pointers. Pointers are awesome. They're powerful. Except when you see pointer, 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 dereference pointer in code. Then you have to figure out what the hell's going on. So with C++, you are responsible for any memory management, any pointers. You as a programmer are responsible. Means that if you mess up, it's your fault. So sometimes you wrote an application, you ran it, and it crashed, and it says, please contact the person who created the program for support. Who created the program? You. So you need to contact you for support. So you have to manage all this stuff yourself. You have to keep track of pointers and dereferences and whether or not you allocate memory, deallocate memory. All of these things was your job. It gave you a lot of things to worry about, but it also gave you a lot of power. With great power comes, at least you got that, okay. So with C++, you can pass things by reference or by value. Something we'll discuss more in the next lecture. With Java, you are free. No more pointers. Don't have to worry about them. Everything that is an object is a pointer, whether you like it or not. Everything is passed by reference, whether you like it or not. You have no control over when memory gets freed, like it or not. So if I have to give you an equivalent, normally with C++, you have to take your rubbish, put it in the dustbin, leave it outside for pick it up to come fetch. With Java, they come in the house when they feel like it and take the trash when they want to. Primitive data types. Now with C++, the size of primitive data types depends on the machine you're running on. Now, in this day and age, most systems, most devices that you're working with are 64-bit machines. What does that mean? It means that on the CPU, one register is 64 bits big. With C++, that is important because it means integers are 64 bits. It means any pointers are 64 bits, and so on and so forth. All depends on the architecture of that machine. If you're running on an older machine, it might be 32 bits, and everything is 32 bits big. If you're running in 20 years' time, 10 years' time, not sure when it's going to come out, 128-bit machines, then you have 128-bit integers. You can hold more data in a single register. So all of that depends on the machine you're working with when you're working with C++. Now with Java, because they have the virtual machine, they fix the types. They say an integer is this size no matter what. And we'll talk about that details in the next lecture. Garbage collection I already talked about in the previous slide. You'll see there that one of the other comments is there's no delete. You can't tell the program to remove or empty something. You can't get rid of that memory. It gets it when it wants to. Your dustbin might be full of dirt, might be overflowing, but they'll come when they want to. So you don't have the luxury of getting rid of it when you feel like. With exception handling, there is no forced exception handling in C++. You could write code that could crash and no problem. With Java, it's very strict. If it thinks it could crash, it'll tell you, as a programmer, please check. Please do something. If there's going to be a crash here, you're going to handle it. Doesn't do it for everything, but it does it for quite a lot of things. You are forced as a programmer to handle those things. Inheritance. So with C++, you can do something called multiple inheritance, and you were told not to. Why? What's the problem with multiple inheritance? What is one of the problems you can experience with multiple inheritance? Diamond problem, where you have a class that has two parents that has a common grandparent. That's a diamond problem. If you look at the UML, you get a little diamond shape. So Java said, okay, that's a problem. We don't want it. It doesn't allow multiple inheritance. One class, one subclass. One class, one parent class. You can have multiple subclasses, but only one parent. There is a way to simulate multiple inheritance to try and get the same benefit without the drawbacks, and that is by using interfaces. Operator overloading. In C++, you could overload operators. You could say plus in this class works like this, minus in this class works like this. The stream operator, stream in or stream out, works like this. When you did friends and you needed to have a class be able to write or read from C out or C in, you could overload the stream operators. With Java, there is no operator overloading. You can't have plus. You have to do a method call, so instance method call parameters. So interfaces, sort of also mentioned a bit earlier, C++ has pure abstract-based classes, whereas Java has something that does pure virtual functions, and it just gives you an indication of what methods you need to overload, so override to actually make it work. Object allocation in C++, you had a way to allocate either by the stack or the heap. So it was either you had a constructor or you had new constructor, and that would allocate either on the stack or the heap. With Java, because all memory management is handled by the virtual machine, you only have heap allocation. There is no stack allocation. Then with multi-threading, so multi-threading is trying to run two pieces of code seemingly at the same time. In C++, it depends on the operating system. You had to have a version that would work on Windows. You had to have a version that runs on Unix. You had a version that runs on Mac. All of it was different. Now, you didn't actually do any of that, but that's how it works. With Java, because they have the Java virtual machine, it's standardized. There's one way of doing it, and it works really well. So we'll learn a little bit about multi-threading, which will become a very important topic when you get to Computer Science 2B. Computer Science 2B is where you start working with networks and you start writing network programs. So you can have one machine talk to another machine to write code that does that. One of the things you need to be able to handle is if you have a web server and you want to handle multiple people visiting a web server, how do you do that? Would it be a nice thing that you have a web server, the first person connects, and no one else in the world can connect to it until that person is done? Does that make sense? No. We want to be able to handle as many clients as possible. So we'll talk about the basics of that multi-threading wise, and then you'll learn about that more in detail in Computer Science 2B. Strings and arrays. In C++, you had string, note the lowercase s, and you had to hash include that. But you also had char pointers, character pointers. And you also had arrays, and arrays was basically pointers. Especially dynamic arrays, they had to be pointers. With Java, strings are built in data type. You don't have to hash include. We didn't do that yesterday when we wrote our Hello World program. It was just string, and it worked. We also have something called string buffer and string builder. We'll talk about that when we get to string lectures. And then when you work with arrays, arrays are actually objects. They're actually some sort of class-like thing. So we can call methods on arrays and do some things with them. And we'll see how that works in the next lecture. All right, so we have about 7 minutes left. So what I just want to have a look at is when you're working with C++ code, you typically you already knew how to do a full class definition. We're not at that point yet. We're still going to get there. So right now, all you really can do is you can write code in the main function, and you can also write functions. Let's see how we can write some functions here. So these are going to be inside of the main, and it's going to have one restriction, this static thing. We'll talk about static in more detail in the next lecture, but what it basically means is that you don't need an instance of the class to use this method. Because when you call main, what's created? What's the first instance that's created? There's no instance. So that's why it's static. But any methods that you call inside of there also have to be static. Now, we saw how to do if statements. So that was straightforward. So you can have something like Boolean. So in C++, you could do bool versus Boolean. That's one change that you might see. You can declare a sort of variable name. So if you do this, then you know this is going to be true part. And then you also have the usual else. And this will be the false part. So that's straightforward. You did that many times before in Computer Science 1B, 1A. For loops we also discussed. So for loops, you have your initializer, your condition, and then your increment. And it works the same way. And you can do whatever you need to do there. So what other things you can think that you did in C++? Switch statements, also available. There's also different types of for loops, which we'll discuss in the next lecture tomorrow. And if you want to write functions, like I said, you could write them now, but you're going to run into a bit of problems with the static thing. With C++, you could have a public section private section, protected section, all these different sections. With Java, you have to qualify each thing with a visibility modifier. So you have to say public for every function, private for every function. It's just something that comes part of the language. So that's cheating a bit because I don't want to write all the code, but that's something that you could do. So that's a function that takes into parameters, calls another function, delegates. Remember delegation? Remember composition? We're going to have a look at those things again. So aggregation, composition, we'll learn about something called realization as well. So all of these different concepts, we're going to have a look at in more detail. So with this, I think I'm going to stop there, and then we'll try and get more detail in terms of the tutorial on tomorrow after I do the lecture. So just to have a look at what we're going to do in the lecture, so just to prepare you for what we're going to actually try and do there. So we'll look at basically what I showed you now, just more formally. Identifiers, data types, operators, character data, input and output. We'll learn how to do input and output. We'll look at hello world again. Then we'll look at conditional statements, so if statements, selection statements, iterators, and flow control. We'll look at all of those things, and we'll see how we can write that code. Some questions? Yes? So we'll talk about static and how that works when we get to working with objects in classes in the first object orientation lecture. But no, they don't all have to have that. Because we're working with main, you have to have things that are static, but we'll find out why when we get to working with that. Any other questions? We'll talk about the meaning of static a bit later. All right, so I'm going to check on the people on Blackboard, but I'm not going to carry on with any more content. So you're more than welcome to leave. All right, so for those of you who are on Blackboard, I am reading the chat right now, and I can see some people trying to give advice to other students, and I saw this in the class yesterday as well. Now, while it's fine to discuss those things amongst yourselves outside of class time, I would prefer that you don't try and teach people things that I haven't taught in class, and there's a reason why we do that, and I would like that to be that I teach the class and not someone else try to teach the class from here. All right, so I don't see any other relevant questions. We'll talk about static, and we'll talk about inner classes and outer classes at a later point in time. If you have any issues with what happens in the lecture and you still want some advice, you can always email me in the learning guide. I'm going to stop the recording now.